Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this problem without any assistance. So let's go over it and let me show you how I did it. So this is question 3044. It's called most frequent prime. So basically you're given this matrix, and for each cell you want to go in all 8 directions and try to generate all the prime numbers that you can. So and then find the most frequent number out of that's greater than 10 and returning -1 if no such prime exists. So also if they're multiples with the highest frequency, then return the largest one. So let's say if 19 and 191 appear 4 times, then you'd pick 191. Okay, so let's go ahead and do this. Let's first traverse this matrix and convert everything to a string just to make it easier. So mat ij is equal to a string of the current cell. So going like this through the matrix. And then here, let's also create a default dict of type integer that's going to hold the global results from all the 8 directions. Cool. So now let's go ahead and actually get all the directions. So let's call this self.directions and let's say 1, 0. So that's down. And then up is the opposite. And then right is 0, 1. Left, 0, -1. And then this way is supposed to be 1, 1. And then, well, let's actually just do this my way. It might be a little more messy, but that's just my way of doing it. So here we're just going to create 8 DFS functions. So let's call up and let's do this. So up with ij with this and with a set. So we don't visit the same cell again as we keep going in that direction until we can't, until we go out of boundaries. So then we're just going to call this current and scene. So again, if we're out of boundaries, or I is bigger than or equal to length of mat, or j is less than 0, or j is bigger than or equal to length of mat, then we just return. Otherwise, we're going to append mat ij to current, and then also add to scene. And then we're just going to also just say if, let's call this digit is going to be int join of current, because these are strings, right? So this is a list of strings. And then, so if digit is a prime, so let's write our own isPrime function, and digit is bigger than 10, then we can go ahead and add digit to the global dictionary. And let's define it as prime function. So basically, if any number is less than 2, it's not a prime. Otherwise, loop from this to num to the power of 0.5 plus 1. And at any point, if num modulo j is 0, return false. Otherwise, return true. And let's go ahead and do this for all the other directions. So let's do this for down as well. Length of mat of 0, right? Then return. I'm sure there's a cleaner way to do this, but again, this is just my approach. Cur.append mat ij scene.add ij. So for each cell, we're going in all 8 directions. And the digit, again, is join current. And if is prime of digit, and digit is bigger than 10, then self.d digit plus equals to 1. And again, we have to keep going in the same direction. We can't change directions. So that's kind of the main point that sort of should jump out to you. So if we're going up, we're just going to be I-1j cur scene. For down, we're just going to go I+1j cur scene. And then let's also do this for right and left. So I'm just going to copy this because there's a lot of logic and it's very similar. and it's not going to be changed, so let's call this right and left. Okay, so we already have down, so let's make this right. And let's say ij plus 1, right? Increasing the column by 1. And left is supposed to be ij minus 1, right? So the column minus 1. And then let's also do down right. Same thing, except just changing that part. Let's call this down right, I plus 1, j plus 1. So this way, and just keep going in that direction until you can't anymore. And then let's call this down left. Again, copy this. Down left is going to be I plus 1, j minus 1, right? Column or row level is increasing, but column is decreasing to the left. And let's do down left, ij, this and set. And then let's do up right, and then up left. So upright and up left. Let's do upright is, okay, not that. Upright is just going to be I minus 1, j plus 1. And then up left is just going to be I minus 1, j minus 1. Okay, cool. At the end, if the dictionary doesn't exist, then we return -1. Otherwise, let's print our dictionary. Okay, so that should give you, see how 19 is the biggest, and then here, 53, 823 is the biggest number with the biggest frequency. Awesome. So now we can call this biggest is going to be the biggest of all the frequencies, all the values of each key. And then let's just loop through. And if b is equal to biggest, if the current frequency is equal to the biggest, then we can call this, put it into a sorted list, sl.add a, and then we just return the biggest of the biggest frequencies, which is the -1. This is going to be the key, the value, right? And then this is the frequency. So let's run this, submit it, and there you go, passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this problem without any assistance and solve it completely on my own. So that's it for this video. Thank you for watching.